Pre-Calc lecture, lesson 118. So, roots of polynomial equations. So, I think we've already talked about this some. The lead coefficient tells you how many roots you can have. So, like, we know that quadratics, you always get 2 roots, and a cubic, you'd have 3 roots, and if you had something to the 14th, it has 14 roots. Now, sometimes the roots are real roots, and sometimes they're complex or imaginary roots. We know that we can find roots by factoring, and roots are just where it crosses, where it zeroes out. You know, like this, there'd be a root at -2, and 3 right here. Okay. So read this part in your book. You should read it. But basically we're going to be finding roots, and we're going to use rational root theorem, which we just learned in the last lesson. We're going to use synthetic division. We know that we can like take a cubic and do synthetic division on it, and then these bottom numbers will give us a quadratic, and then we can either put it in the quadratic formula or we can do a diamond problem on it or something. If something has a imaginary root or an I in its root, complex root, they come in conjugate pairs. So if there's a root that has 1 plus I, you better be looking for another root where it's 1 minus I. Okay, they always come in conjugate pairs, and that's, you can kind of imagine why. Because when you get those i's come out when you get a negative underneath your radical right here in the quadratic formula. And then you get the positive version and the negative version. So they come in pairs. They come in conjugate pairs. So you're supposed to know that. And basically we're just going to start factoring or finding roots of a lot of polynomials using a lot of different techniques that we know. You can see that they're using a lot of synthetic division. That's pretty much the technique, is keep using synthetic division on it until you get it down to a quadratic, and then you can use quadratic formula, or if you're having a good day, you can factor it. Okay, I'm supposed to do 118, number 8. So it says 4x cubed minus 4x squared minus 5x plus 3. I'm supposed to find the roots. So since we just learned the rational root theorem, I'll go ahead and find out what my candidates are. Now again, I've probably said this a zillion times, I usually won't do rational root theorem until after I tried 1 and -1 and they didn't work. That's when I'll break out this thing. But since I just taught it to you in the last lesson, I took all the factors of the constant, which are +1, -1, +3, -3, and then I put them on the top of a fraction bar, and then I took all the factors of 4, which is ±1, ±2, and ±4. So as I'm doing my synthetic division, I'm going to only try things that are, 1 and -1. I can try some fractions if I want. I could try a half. I would never try 2 because there's no 2 up here. You know what I mean? I could try 3. So usually what I'll do is I'll try the integer roots, like 1 and -1. Then I would try 3 and -3. Then I might try a half and -1/2. And a fourth and -1/4. Those are the only things it could possibly be. In this one, I already did it, and I tried 1, and it didn't work, because 3 minus 5 is not 0, so that didn't work. But then I tried -1, and I got a 0 remainder. So that means that x plus 1 is, you take the opposite of that. That means that x plus 1 is a factor. And then these, I just put an x squared and an x on them. I kind of pared it down by a degree. It was a cubic, now I got a quadratic. Then you might as well go ahead and try to factor it. I actually got lucky. I factored it and it worked. Otherwise, you're just going to use quadratic formula on it. So I wanted something that multiplied to make 3 times 4, 12. And I want it to add to make -8. 3 and 4 didn't work, but 6 and negative 6 and negative 2 work. Okay, then I have this area model box. The reason I have to use the area model box, oh, I didn't finish it, is because I have a coefficient that's not 1 in front of my x squared term. So I thought 2x times 2x can multiply to make 4x. 2x times negative 3 would give me what's inside this box. 2x times something is negative 2x, so I guess that means negative 1. And then check it, negative 1 times negative 3 is 3. So now I know my factorization is 2x minus 1, 2x minus 3. 2x minus 1, 2x minus 3. Now I'm trying to find roots. So this one's easy. This will be x is negative 1. This one I can kind of do that in my head, and I think most of you guys can. You bring the, I'm setting it equal to 0. Bring the 1 over to the other side of the equation. Divide by 2, that's going to give me a half. And I think you guys can handle this. It's going to give me 3 halves. Now, are these all, would these have come up over here? I hope so. If I got something down here and it didn't appear up here, I would kind of think I must have done something wrong. But see, 3 halves is one of the candidates there. 1 half is also a candidate, and 1. Okay, and that's it for this lesson.